Especially for mobile front, mid and backhaul optical connections, DWDM is the ideal technology to reduce the required number of fibers down to the absolute minimum. Now the big question is, what is the ideal transceiver technology to be able to handle all those different wavelengths? If you want to find out more, stick around and we'll check it out. Let's start off by laying some groundwork. We are talking about the ITU DWDM grid with 100 GHz channel spacing. To be more precise, we're talking about the channels ranging from C14 up to C61. Now, within this category, we actually have three main technologies for transceivers. First of all, we've got the transceivers with fixed wavelengths. In other words, we have different transceivers for the different wavelengths. We then also have the tunable transceivers, in other words, one type of hardware that then can be tuned to the different wavelengths. And then we also have the auto-tune transceivers, which automatically tune to the right channel when they're plugged into the system and they have their counterpart auto-tune transceiver. Now, to be able to compare these different technologies, we're going to have a closer look at the pricing, the operational efficiency, the impact that changes to the channel plan have, and also the availability. So let's get started. Now, from a pricing point of view, the transceivers with fixed wavelengths are by far the most cost-effective solution. And if we compare the tunable transceivers to the fixed wavelength transceivers, you will see in this very simplistic diagram that the tunable transceivers are roughly 3 to 5 times more expensive. And if we then compare the auto-tune transceivers to the tunable transceivers, well, they are an additional 20% more expensive compared to the tunable transceivers. Now, if we have a look at the operational efficiency, the fixed wavelength transceivers, the commissioning is really simple because you just need to plug them in, wire them up to the multiplexer, and that's it. So you've got no tuning or anything else that you need to do up front. But the lack of tunability is also the biggest downside of the fixed wavelength transceivers, because we then have a large variety of different transceivers, meaning we have a very large inventory. And also, the in-field service becomes quite complex, because if we need to replace a transceiver in the field, we need to make sure that we've got that very specific transceiver for that wavelength available and handy. Now, the tunable transceivers, they have the big advantage that we've only got the one hardware. So that means we have a very small inventory, and also the service in field becomes relatively simple, because we need to have that one type of transceiver, and then we need to tune it to the wavelength for the transceiver that we want to replace. Now, the tuning is the small hiccup, really, because we need the equipment, the network equipment doesn't support the tuning most of the time. So in other words, we need an external device to be able to tune the transceivers. But it really is only a small hiccup, because there are options out there. We, for example, have the Q-Box for our HUBER+SUHNER transceivers, meaning you just plug it in, you've got a very simplistic software on your smartphone or computer, and then you set the wavelength. And in addition to that, the Q-Box you can also then use to change the compatibility coding to that is required for the equipment that you're plugging the transceiver into. So it's not really a big hurdle, but you need to tune the transceiver, otherwise it won't work. Now, the auto-tune transceiver, well, the idea of the auto-tune transceiver is to get rid of the necessity of a tuning box. So you plug them in and they automatically tune themselves. That means that the inventory is also very small, but the auto-tune functionality itself, ironically, is also the biggest downside, because the tuning process itself requires a certain amount of time, and it's not a fixed amount of time, it's a variable amount of time, so it can take a couple of seconds up to minutes. So, and the other thing that it makes it a little bit more complicated is that there is no indication in regards to the tuning process. So you don't know if the process is still ongoing, if it has locked on, if it has failed or so. So in other words, commissioning a system with auto-tuned transceivers can take a long time, and also, which becomes really challenging, is then the in-field servicing. If the auto-tune functionality doesn't work, the troubleshooting becomes very complex. Now let's have a look at the availability and the channel plan changes. So availability, the fixed wavelength transceivers are very widely used in the industry, and they're readily available, but only for the wavelengths C20 to C60. You can also get the other wavelengths, but they're very difficult to come by, and a lot of times they tend to be then very expensive. Now, if we have channel plan changes, the big downside of fixed wavelength transceiver is you then need to replace those transceivers. Now, the tunable transceivers, they are also widely used in the industry, and because we can tune them, we can actually tune them to any of the wavelengths from C14 up to C61, and they're also very readily available. Now, if we've got channel plan changes, that is also quite simple, because we take the transceiver out, we plug it into our tuning box, and we tune it to the required new wavelength, and that's it. The auto-tune transceivers, here as well, we've got the full range of wavelengths, and which is a benefit is that as soon as you hook it up to the new optical multiplexer, it will auto-reconfigure, so you don't even need to take the transceiver out of the system, but it will do the tuning itself. But there is one very important thing still to mention for the auto-tune transceiver, and that's the interoperability between auto-tune transceivers from different vendors. Now, for a few years now, we've already had the Smart Tunable MSA, which specifies a auto-tuning protocol to make an interoperability between different vendors possible. But the manufacturers generally tend to still stick to their own proprietary protocol, meaning that the auto-tune transceivers between different manufacturers are not compatible to each other. And that is quite a downside, especially when you're trying to find a dual source. Now, as usual, with these sort of technologies where we've got multiple to choose from, there is not that one sweet spot. It all very much then depends on your individual network and financial requirements, and also what you are willing to invest in regards to serviceability. But I hope this video helped you to get a better overview so you can make the best choice for your network. And of course, remember, if you have decided on one, get in contact, because we can offer any of these solutions. So I hope you enjoyed this video and that you learned something today. If so, please leave a comment. And of course, remember to follow our channel so you get your regular dose of brain snack. Until next time, bye-bye.